The following video will demonstrate how to set up and solve a multi-objective optimization problem using a non-gradient based optimization method in VisualDOC. I will be using a vehicle side impact model to demonstrate the creation of the Pareto optimal front using non-dominated sorting genetic algorithm. The vehicle side impact model used is an approximation model generated using response surface after performing LS-DYNA simulations. The vehicle is designed to be simultaneously light and safe. Thus, the design objectives for this problem are the weight of the door panel and the velocity of the door upon side impact. These two objectives are conflicting because if the door panel is light, it may have a higher tendency to deform and impact the occupants with a higher velocity. The design parameters and constraints for this problem are as shown in the slide. Now let's start by opening VisualDOC. Create a new project. Next, I will create a workflow. From the component palette, add an optimization component. Next, add the executable wrapper component inside the optimization component. Now add a stop block. Next, I will connect the components in the workflow. Now the next step is to set up the executable wrapper component. Go to Component Editor tab. Select the executable wrapper component in the Model Tree panel. Enter the input design parameters and responses in the middle panel. In the input-output column, select Input for the input design parameters and select Output for the responses. Enter the initial values. The barrier height and barrier hitting position are non-design variables. Thus, select Constant in Advanced Attribute column. Now in the panel on the right, under the Run Location section, make sure that Analysis Runs Locally radio button is selected. For the analysis working directory, make sure that Use the Model Directory option is selected as the directory part type, as I have saved my VisualDOC model in the same location where I have saved my analysis program file. The analysis program file is an executable file which is used to evaluate responses. When coupling analysis with optimization, it is necessary to have an input and an output data files. The output data file is utilized to extract the output responses, and the input data file is utilized to override values that corresponds to the design variables. For the local analysis program definition, make sure that Relative to Analysis Working Directory option is selected for the file part type. Now click on the file icon and select your executable analysis file. For the input and output file definition, make sure that Relative to Analysis Working Directory option is selected for the file part type. Now click on the file icon and select your input file. Similarly, for the output file definition, select your output file. Now for the program arguments, enter the name of your input file, space, name of your output file with their extensions. Now push the test button to ensure the interaction between VisualDOC and analysis program. Now the next step is to create data transfer needed for the optimization component. Go to Data Linker tab. select Optimization component in the Model Tree panel and in the middle panel. Make sure that Auto-Link checkbox is selected. Now click on Automatically Add Data to Selected Model icon. This will add the corresponding links for the data transfer between optimization and the executable wrapper component. Thus, all the design variables and responses will be added to optimization component. Now the next step is to set up optimization component. For the weight and door velocity, check the checkbox in the objective column. Make sure that Minimize option is selected in the goal column. For the weight, uncheck the checkbox in the Constraint column. Now I will enter the bounds. From the panel on the right, for the optimizer, select Non-Gradient Based Optimization. Select Non-Dominated Sorting Genetic Algorithm or NSGA2. For the starting strategy, select Random. This will allow the user to create a random set of initial points. The number of points is specified by the associated population size. Enter 20 for population size. Under GA parameters, for the probability of mutation, typically value is set to 1 divided by number of design variables. For this problem, the number of design variables is 9. Thus enter 0.11 for the probability of mutation. Keep the default values for all other parameters. For the stopping criteria, set the maximum number of iterations to 200. Now I will create a Pareto optimization monitor to plot the relation between two conflicting objectives. Go to Simulation Monitors tab, add an Optimization Pareto monitor. Click on Expand Hierarchy icon below the Flowchart Components panel as well as List of Monitors panel. Now drag the weight under Optimization and drop it on the X1 axis of the monitor. Similarly, drag the door velocity under Optimization and drop it on the X2 axis of the monitor. To activate the monitor, you can either click on Enable All Monitors icon or in the panel on the right, mark the checkbox under Enabled column. Now click on the Validate icon. Now click on Run icon to execute the optimization. To view the defined monitor, click on View Monitors tab in the message area. VisualDOC has the capability to provide real-time updates. When the simulation is underway, the simulation monitor gets updated in real time. In multi-objective optimization problems, it is important to study the relation between two conflicting objectives, as the minima of door velocity is the maxima of weight and vice versa. Thus, the aim is to find the optimum solution which will reduce the values of both objectives simultaneously. To view the optimum results, go to Component Editor tab. The table displayed in the middle panel has the optimum values in the optimum column. The optimum value for the weight is 27.34 kgs and the optimum value for the door velocity is 13.60 mm per milliseconds. This completes the demo. I hope that it has helped you to learn how to set up and solve multi-objective optimization problem using non-gradient based optimization method in VisualDOC. If you would like to learn more, I invite you to check other videos about VisualDOC. For more information, please visit our website at www.vrand.com or email us at visualdoc.support@vrand.com. Thanks for watching.